We're either getting applause or something.
Jeez.
You have asthma?
Hello.
Hello, Ben.
Hi.
He uses like an earbud or something like that.
No, I'm not.
No, not anymore.
No, I'm not.
What are you using?
A laptop.
Ah, that's why it sounds so much better.
Yeah, I said that to you last week.
I know.
So why are you asking me again?
Your sister said something today in class. I didn't really hear her fully. Is she around?
Maybe? Yeah, I can go get her.
Yeah, go get her. I just want to make sure I understood what she was saying.
Okay.
She either was saying, I'm sorry for something she said, or she was saying something like, you need to apologize for something you said, Mr. C.
Mr. C wants to talk to you.
That's crazy.
Okay, I got her.
Thank you, Ben. She there?
A simple yes or no question.
Oh, I'm muted. Okay, yeah, here she is.
Yes.
Elmer, were you saying you were sorry for something you did, or were you asking me to apologize for something I did?
Oh no, I was saying I was sorry that I wrote on the board the answer.
Yeah, that's what I thought it was. You're fine. Don't worry.
Okay.
We're good. Right, later.
Mom's going to expel you, Ella.
Oh, okay.
Yeah. All right, thank you. Goodbye, and I'll leave.
Any questions?
Can I go to bed for half the class?
Yes.
Oh.
I don't understand what number 4 was at.
So number 4 says, name the graph of the ordered pair 0, -2. So find 0, -2, and what points at 0, -2?
D.
This is a graph.
I have a question.
So it's a verb. So when you graph something, right, it's saying, you know, what does it look like? So it was just saying, name the graph of this. Meaning like it was just saying, what is graphed at 0, -2? Ben?
Yes.
Ben, question or no?
Yes, number 18. I just want to make sure I have the right answer.
Which of the following points lies on a horizontal line through W? So I'm looking at W, and there's no other point, so they're giving me options here. So let's see, horizontal would mean that the Y-axis would not change. So let's see, the Y value of W is -3, so whichever one has a -3, looks like 2 answers. And it does say which of the following points, plural. So C and E would be the answers.
Okay, that's what I
They
got.
have a Y
Thank you.
value of -3.
I didn't think about that. When I read it and I thought it was like singular, and I was like, wait, there's 2 answers.
Yeah. All right.
Good
Here we
day.
go, real quickly. Let's see. Number 1 is 3. Number 2 is 2. Number 3 is 0, 0. Number 4 is Z. Number 5, where are the answers to 5, 6, 7, 8, 9, 10? I don't see them.
It's 3, 5. Then it's
5 is 3.
4, 3.
Oh, I found them, yeah. 3, 5 is 5. 4, 3 is 6. 4, 0 is 7. 0, 4 is 8. -5, 0 is 9. -4, 3 is 10. -2, 2 is 11. -4, -2 is 12. -2, -3 is 13. And 3, -2 is 14. 15, the answer for 15. Why does this book make it so hard? KOS. 16 is ORZ. 17 is
There's a
3.
mistake. There's a mistake. O is on a line, therefore it is not in a coordinate.
So he's saying 16. Name all the points that lie on the y-axis. I would agree
Oh,
with
I
you,
thought
Ben.
you were doing coordinates. Never mind.
No, I would agree with you because O is the origin.
Yeah, but it's still on the line.
Okay, so that's what their
But
argument
it's
is going to be.
technically not on the line.
I would not have put O. I would have
It's
put
just
just S and K. I'm sorry.
And that's
I'm sorry. R and Z.
So-
I would put. Yeah, I mean, don't worry about that one. R and Z is what I would have put. I wouldn't have put the origin. Yes, the
Okay.
origin of the point, but I mean, obviously, you would have thought they were talking about the illustrated points. Let's see, that was 16. 17 is 3. 18 is C and E. 19 is M, N, P. 20 is T and U. 21 is V and W. 22 is J and Q. 23 through 34, I will look at your graphs. So we'll pick it up at 35. 35 is 2, 1 is the midpoint. 36 is 2, 5 is the midpoint. 37 is 0, 3 is the midpoint. 38 is -3, 0. 39 is -4, -2. And 40 is 1, -1. Done.
Okay.
Henry, what do you plan to do when you get older?
History teacher.
History teacher. You're going to be very entertaining.
I will definitely go to your class.
All right. Chapter 4 is really cool. Really cool. So here's the big picture of Chapter 4. Chapter 4, quiz on Friday. Test on next Thursday. I will tell you, I rarely, for the advanced class, like there's occasions when we don't make progress, but I mean, rarely. Like the fact that the quiz falls on a Friday and we got to teach a class, I can almost bet I might not get through that class. But other than that, you know, like on Fridays, there's 2 Fridays in a row. Other than the fact that Fridays are short, I usually, you know, we just speed right through this material. The at-level class, you know, they're on track with us right now, but I bet you we get off track in this particular chapter because sometimes it takes longer to wrap your head around what's going on. But I don't expect you guys to take too long. I'm going to take it here in a second. All right, here's your homework. It says you need graph paper. It's not lying. You need graph paper. You don't want to do this by hand. Not all the questions, but just a few of them. And you'll see why when you do the homework. You're not going to want to do, it's not every question. It's just a few questions if you want to. I don't have the book open, but if you do, you'll figure out which one. Let's see. You be drawing a couple triangles or octagons or something.
I thought we were doing triangles for a while.
No, this entire chapter is about triangles.
Oh, okay. So we're finally getting triangles?
Oh, and we never leave. From this day onward, nearly every, I bet there's not a single day we don't do a triangle. I bet.
Really? Really?
Constructions might be the one exception. Like the first day of constructions, first 2 days, I don't think we do triangles. But every other day, we learn to do a triangle.
What? Yeah, what about spring break? What about spring break?
Well, that I teach.
You could argue that
I'm saying in class. We're not, I mean,
What if I'm gone?
well, then you're not here.
Teach me a triangle.
All right, moving on. All right, congruent figures. We made the observation before that you can take any polygon, draw diagonals, and you make triangles. So since any polygon is a collection of triangles, we spend a lot of time on triangles because triangles applies to all polygons. Now, it doesn't apply to, you know, circles, although you can kind of force it to slightly, but it's more of a rounding with triangles. But for polygons, it's true. You can make any polygon into a collection of triangles.
You can make a triangle out of a circle.
We will draw in a circle triangles. In fact, we'll get a couple theorems and postulates or theorems from that one, and that's how we actually make sectors is with a triangle. Okay, so congruent figures. Write this down in your book of truth. You see how much space is here? It's going to take a while, a few slides, but we're going to fill this whole thing in with definitions. So you're going to want to write, this is your first, your book of truth, then a second thing, and a third thing, but it's going to take me a while to come back to it, this slide. All right, so congruent figures, these are 2 figures. It doesn't say what kind of figures. It just says 2 figures that have the same size and the same shape. And I've already said that this chapter is about triangles, so let's just go ahead and draw a triangle. Right? Now it says figures, plural, so we're talking about more than one. So if you are a congruent figure, you have to have the same size and the two things, same size and shape. So here's my first figure, right? If I want to make one congruent to that, well, it's got to have the same shape. Well, if that's a triangle, then my other one must be a triangle, and it must have the same size. Now, the reason why we have those two caveats right there is because you could have the same size, but you could be a different shape. In other words, the area of this triangle would match the area of a rectangle, right? But clearly they're not the same shape. So we have those two things. Now, the question is this blue one the same as this green one?
Yeah, no.
Well, could you prove it from that picture right there?
No.
So even though it looks similar, right, we would have to do, you have to tell me some values to prove that they are the same shape.
I have to tell you either the angle measurement or the size.
And that's kind of where we're going. So there are other ways to show that the two are congruent. In other words, they're congruent figures. And that's what this whole class is about, is how could that process be done? So it turns out I literally just made these the same. And all I did was take one and just rotate it, 90 degrees. This right here is our first method of telling that two shapes are congruent. This is a statement. Guess what we call this statement? We call it literally a congruency statement. And a congruency statement literally states that the two shapes have the same size and the same shape because of that congruent symbol right there. So this is telling us that this blue triangle is the same as the green triangle. Now, if you needed more convincing, I guess the only other way I could convince you is if I laid one on top of the other, right? If I turned it and then just, physically moved it. Now, I didn't do a perfect lining them up, but you get the idea. Right.
It makes a 3D shape.
Oh, yeah, it does.
Could make a triangular prism,
I mean,
right?
If you look at it,
Yeah.
it's an outline.
But I really, truly intended for those to line up perfectly. Okay,
Also, the letters are little.
so in box 1B, or 1A, not in your book of truth. We don't need to write this yet. In the book of truth. We need to write this down, though. If two shapes are congruent, then they're going to have what are called corresponding parts. And corresponding parts are the parts of the congruent figures that are the same, that match up, that lie, if you put one on top of the other, that would match up perfectly. And we're talking about both angles, and we're also talking about sides. We're talking about figures. You could have two congruent circles, right? So the circumference of one would match the circumference of the other.
Isn't every circle as long as it's the same size? Right?
No.
No? Okay.
Oh, if they're the same size, yes.
All right.
We will prove that, right? But not in this chapter. We won't do it with any circles this chapter. It turns out that any two circles have the same radius or the same diameter or the same circumference are congruent.
Because they're all
Obviously, right.
But isn't
And it's an easy thing to prove.
Every single one add up to pi or some?
Well, you take the circumference of any circle and divide it by its diameter. That's what we define pi as. Okay, so back to this corresponding parts. Those are just I always talk about identical twins. If you have two identical twins standing in front of us, we say, raise your right hand. I'm raising my left, obviously. Raise your right hand, then they both raise their right hand, and they look exactly alike. If I ask the one of the twins to turn this way and raise their right hand, well, they're still the same hands, and they're still exactly the same thing between the two, but they're not in the same orientation. Well, then I chose poorly for demonstrators, okay? But that's the kind of idea. If you have two things that are the same, doesn't matter which way you turn them, their corresponding parts are the same. Okay, so what are the corresponding parts of these two triangles?
All of it, like the sides, the angles.
Remember, the idea is that I take this green one and I lay it directly on top of the blue one, and what parts match up? What parts match up?
Angles, sides, exterior.
So, specifically, what parts match up?
The top, the
Specifically by name, what parts line up?
vertices.
Specifically. So line DE or segment DE would match up with with AB. What else would match up?
EF with BC and FD with HCA.
What else would match up?
And then like
The entire circle.
Yeah. So
angle E, angle B.
the angles would match up. In other words, angle A, this means corresponds to, the little arrow means corresponds. So angle A would correspond to angle D. Also, the arrow can also mean implies, right? But we'll say correspond here. Angle B corresponds with angle E, and angle C corresponds with F. And then you told me the sides. You said that AB. Now, you got to be careful with the sides. If you call this side AB, then the one that lines up with it is not ED, it's DE. So however you name the first one, orientation-wise, is how you would have to name the second one.
Why?
That's just how we roll in
But it doesn't
geometry.
make sense because ED is still congruent to the AB.
Yeah, this is kind of the weak one in geometry, but that's how we do this.
Aha,
Right.
you think you're wrong.
All right. Let's see. BC would line up with,
B, E, F, E, F,
and CA would line up with,
FD, F.
and if you said DF, I would take like a half point off, right? So the way the order that you name the first one has to be the order of the second one. You'll see why here in a second. Okay. Well, this is all cool and really easy to do, right? The but here is that I can flip this around and then all of a sudden bad things
But you
happen.
can clearly tell that they're still the same shape. BE is still equal to AB. BC is still equal to
Right.
F.
But here's what I'm going to say. I can also take this thing and flip it around like this, and then it becomes a bit more complicated to figure out, wait a minute. Notice that these two are, I mean, okay, maybe you can sort of see which one lines up. It just makes it a little bit more challenging. So this issue of the fact that you can take one shape and flip it and rotate it, and then you're still asked to line things up, can be a bit of a challenge. I mean, this is your classic IQ test. They give you two shapes, and you're asked to somehow fold it, twist it, turn it in your head. We have three other ways that we can accomplish this. Instead of flipping it, so there's four total. The first one is you got to be able to flip this and rotate this in your head. The second one is the congruency statement. It's the easiest of the four. So the easiest of the four is if you have a congruency statement, we'll check it out.
They're congruent.
What's the first letter?
A,
Well, what's the first letter?
B.
Notice this wasn't just haphazardly written. It's written in a specific order. The first letter corresponds with the first letter. Also for sides. Side BC, that's the second and the third letter here, would correspond with EF, second and third letter of the congruency statement. So if you have a congruency statement, you don't even need to look at the picture. You get all those corresponding parts just by looking at the congruency statement. But guess what? You don't get a congruency statement all the time. Sometimes they'll ask you to, if these are congruent, write the congruency statement. But most of the time, they'll say that these two are congruent. Now find the corresponding parts without a congruency statement. So I said there's four ways. The first way is that if you just visually twist it, turn it, right? That's the first way. The second way is to look at the congruency statement. So we'll pause for a moment and look at the congruency statement. So the congruency statement is how you tell the corresponding parts. All right, so once again, we can get all this information. So McKinley, give me an angle.
B, C,
Angle.
A, B,
And B would correspond with
E, yeah.
E. Okay, that's pretty easy. All right, give me a side, Jack.
C,
BC would correspond with EF. Give me an angle. Would correspond with McKinley. Okay, so you got that idea? I just got to make sure you understand that whichever way you tell me the letter, you got to match the congruency statement if you have a congruency statement. Okay. All right. So the consequence of the fact that you have corresponding parts of congruent figures is the fact that if you have congruent figures, then what about their corresponding parts? If you have congruent figures, what do you know about the corresponding parts? They're congruent. Well, that's a big, long sentence that has a lot of meat to it. All right. So we started off by saying two shapes are congruent. We can either get that through visually looking at them or from the congruency statement. We talked about the corresponding parts. The consequence of these two statements is that the corresponding parts of congruent figures are congruent.
But we could get that from common sense.
Yes, and that is common sense. That's why this is a definition, not a theorem. We didn't need to prove this. We didn't need to write as a postulate. So one more thing that we get from this. So we know that the parts, the corresponding parts are congruent. One quick, I'll throw these all up here again. One quick statement. If angle A is congruent to angle D, what does that literally mean?
Angle A is the same measurement of angle B.
So I can make that statement.
Yeah.
If side AB is congruent to side D, then what can I say?
Or AB is equals to DE.
You get that statement right there.
Aha, so I can use it in a proof.
You can, you will, by the way. All right, so when you get to your corresponding parts, not only does it mean the corresponding parts are congruent, it means their measurements are equal. We're not saying that the angle equals the side, but we are saying the corresponding parts are congruent and equal by the definition of congruence. Definition of congruent says if something's congruent, it means their measurements are equal. All right, so back to our book of truth. We already have that written, right? We have our consequence now, write that down. So the consequence is that corresponding parts of congruent figures are congruent, and then I got parentheses, their measurements are equal. That's not really two different statements, it's the same basic statement. So we can say corresponding parts of congruent figures are congruent.
But can they not be congruent?
Not if they're congruent figures.
But what if it was congruent originally, but then I push it
You
over?
can dilate it and then they're no longer congruent. We will spend a lot of time, either the end of this chapter or it's the end of next chapter on something called similarity.
Similar figure.
Similar figures. They're not congruent, but they're similar to each other. All right, so we got this. We got this long mouthful right here. Oh, by the way, what shape are we going to be dealing with this chapter? So instead of saying congruent figures, we would say congruent.
Triangle.
So you get corresponding parts of congruent triangles are congruent. That's going to be the last line of nearly every proof we do from now on. So a long time ago, people looked at this and they're like, wait, you want me to literally write corresponding parts of congruent triangles are congruent? And then some smart aleck kid said, I'm not going to do that. I'm going to write CPCTC. So here's how your proof is going to end. I'm not literally saying, well, I am literally saying it, but I'm saying it's going to be many proofs that will have this. CPCTC. And all it means is you have two triangles that are congruent, therefore you can claim that their corresponding parts are congruent. And nobody wants to write that out, so they just write CPCTC. If you have, when you walk into a geometry classroom from now until the end of the year, you're going to hear universally, no matter what country you go to, now obviously they're going to have different words for CPCTC, but they're all going to say CPCTC because nobody wants to write that. And you use it in nearly every proof. Cool? All right, not a hard class today. All right, one more definition. Congruency statement. This is the statement that indicates which specific parts are congruent or which measure. That's the same basic idea. No, it doesn't. You don't need to. We're not going to use that as a definition. But we are going to, tonight for homework, we're going to make congruency statements. It's just a statement that indicates which parts are congruent. If you have congruent figures, well, you got to tell the reader which parts match up. This is like the gold standard right here. When you get a congruency statement, you're like, oh, thank God I got a congruency statement. Because it's really simple to match things up. I don't need to look at a picture because I have the congruency statement. And even though that we're going to be dealing with triangles mostly, this also applies to any polygon congruency statement. You know, this pentagon is congruent to this pentagon. There's your congruency statement. Only problem is you got to name 5 letters in a pentagon instead of 3 letters in a triangle. So hopefully you don't have a 21 gon because you're going to be writing a lot. If it's a 27 gons, you're out of letters. So that's when they start using subnotation. Okay.
So can I go watch Wall-E now?
No.
No?
So you could literally just write a bunch of triangles up.
You could write A sub 1, A sub 2, A sub 3, A sub 4. There's your.
Or A sub jack, A sub.
You could. A sub blue, A sub red, that's
Or I
white.
could make up my own letters like the.
You can, right? All right. So this is the example. We've already seen this before of a congruency statement, right? So let's see. One more time, and then we'll call this one a day. Number 2. Just go around the room. Go, McKinley.
H.
Okay, but make sure you say angle H. Go, Jack.
Oh, F, angle Q.
Go. Ben,
What?
next one.
FQ equals KD.
That's wrong.
Line above KD equals line above.
Wrong.
Wait.
Line KD.
FQ equals KD. KD. Line KD.
Say it again.
Line FQ is congruent to line KD. As I said,
You're like one little tiny bit off.
congruent to line KD.
Those are not lines, Ben.
Segment.
Segments KD.
All right. Who we left off on?
Me.
Go.
Oh,
And then beginning.
line above HK. Segment HK.
Okay. Good. All right. And I do want you to remember that this also applies to the measurements as well too. So we could also say that the measurement of angle R is equal to the measurement of angle H. All right. And same thing for segments. And just remember, you guys tend to forget this, is that if you're talking about equality, we take the line segment off. We're talking about angle measurements, then we got to put the little tiny little M there for measurement. Okay, I had another one. Period 2 didn't need it. I'm sure you guys don't need it as well either. Okay, so I said there was 4 ways to show that parts are congruent if the figures are congruent. So the first one is you literally just look at the shape and you line them up in your head. The second one, the easiest one, is the congruency statement. Then we got ways 3 and ways 4. Here's way 3. They're going to give you 2 shapes, and they're going to have a whole bunch of red markings on it. It will look something like that. Okay? I have 2
Yeah,
triangles.
that's super easy. All I have
That's
to do
just the
is,
same triangle flipped over.
Okay.
but why is it bendy? What purpose?
Because when I took a picture with my iPhone this summer, or whenever I did this 2 years ago,
Yeah.
it's right. If you look in your book, it's figure what? I took this picture right here. So it was literally like this, and that's why it's curved like there, is because when I put my hand to flatten it out, that my hand was in the picture, I was like, oh, I'll just do it with it curved. Okay. So when you have these congruency markings, remember sides are made with tick marks, angles are made with arcs, right? Well, then all we have to do is look at the markings. But what's the congruency statement?
You get one part of this.
Well, the first thing I got to do is I got to at least say the name of one of the triangles. So, for instance, if I pick the first one, and for instance, I say this is triangle RAY, right?
You just have to
Or ARY, sorry.
SUN
All right, well, how do you know?
because it matches up.
Because you did, that's how you did it.
Well, if I start with A has how many arcs?
One.
And the one that has
Actually, a
1
lot,
is
considering all the curves.
U. All right, and then 2 is, I'm sorry, R has 3, so the one that has 3 is S. And Ariusen rather than
Sun.
Ray
Sun.
Sun.
Ray.
All right, the book likes to do this. I'm just going to point this out. You're going to see this a couple times where they literally have things spell out words.
Ray.
All right.
Ray.
Now, from that, once you have that congruency statement or not, I don't need a congruency statement if they give me literally every little bit of information. I could have made these congruency statements right here simply from the fact that, well, they gave you all the information on the picture. So, for instance, R goes with, A goes with, and Y goes with
And
Ray Sun.
so,
All right, AR goes with segment US, RY goes with SN, and YA goes with Yanu. All right, do we need to do another one? We got this one. Oh, this one's nice and flat.
it is still bendy.
Is it still bendy?
Bendy.
Not as bad as that.
Look at the
This
bottom
one.
one. Look at the bottom.
Okay, the F is right. Okay, good.
Yes.
So I said 4 ways, that's 3. The 4th way will be, instead of congruency markings, they will give me measurements. So for instance, instead of saying angle C has 3 arcs and angle E has 3 arcs, it may say something like angle C is 60 degrees And angle E is 60 degrees. Instead of saying that AC has 2 tick marks, I might say AC is 4 centimeters and ED is 4 centimeters. So those are your 4 ways. You either have to literally, like they won't give you any markings, any congruency statement, then you got to by your eyeball or by your brain, flip it around, rotate it, turn it, and match the 2 together, right? Or you have a congruency statement. Where's my congruency statement? Or they give you congruency markings, or they give you actual measurements, right? Those are the 4 ways that you match things up. All right, quick note. This applies to all polygons. So even if this was a pentagon, right, we could still apply the same concept.
What about 100?
An n-gon of 100? Sure, we could do that as well too. All right, write this down in your book of truths. This is not a postulate or a theorem. It should be. The book doesn't call it a postulate. This should be a postulate, right? It should be a theorem at least. It says 2 polygons are congruent if and only if their vertices can be matched up so that the corresponding parts are congruent. So basically it's telling you, how do you determine if 2 shapes are congruent? Well, you got to match up all the angles and all the sides and see if they're the same. If they're the same, then you can conclude that the 2 figures are congruent. So 2 polygons are congruent if you match up their vertices. If you match up the vertices, you're also matching up the sides. And when you match up the vertices, all the corresponding parts must be congruent. If that's the case, then the 2 figures are congruent. What's the key words up there right here?
If and only if.
So this is a
Biconditional.
biconditional. So you get 2 statements, right? And both of them are true, right? When you have an if and only if, it's a biconditional. That means the first part is true. If the first part is true, the second part is true. It also means if the second part is true, the first part is true. So here are the 2 statements. So give me both statements with hypothesis and conclusion.
If their corresponding angles are congruent, then 2 polygons are congruent.
Or
If 2 polygons are congruent, then their corresponding parts.
those are your 2 statements. If the polygons are congruent, then the corresponding parts are congruent. If the corresponding parts are congruent, then the polygons are congruent. So you get that both ways. And I have a problem with the book, and I'm not claiming that this is a postulate at least, if not a theorem. We just say it's a definition. So it's in your book of truth, now it's true. And it is a dull one. We don't really need it. Okay, if everything matches up, how could they be different from each other? And the answer is they can't. So I'm claiming that that's a postulate, but they don't. Cool?
Yep.
So how do you prove that 2 angles are congruent?
We're looking at
2
this.
triangles are congruent, sorry.
CBC.
No.
2 polygons are.
How do you prove that 2 triangles are congruent?
Oh,
If
right.
they're
Their
the
corresponding
same
parts.
So how many things you got to prove?
4. No, 2.
one.
Why 6?
Because you have all of the angles.
I got 3 angles and I got
3 sides.
3 sides. I'm going to have to prove 6 different things to show that 2 triangles are the same. Sounds like a lot of work?
Not really.
Heck yes, it's a lot of work. You got to show 6 things. Your proof's going to be that long. Or maybe there's a shortcut.
Yeah, that's what
The rest of the chapter is about
Shortcut.
shortcuts to that method. So God forbid if I give you a 10-gon.
Ah.
Now you got to prove 20 things are congruent if you only have this. Luckily, we have shortcuts. Okay? So the rest of the chapter, and in the next chapter as well, is about, well, what are the shortcuts to show that 2 triangles are
Well,
congruent?
if I divide 100 gone, divided by 6, you get 50. Then you can divide that by 3, 10, and then you get 5.
and then
just have to do
wait.
5.
And now you ready for,
Whoa, wait. 50 divided by 3.
No, I said.
if you take a regular polygon, say for instance a hexagon, you take a regular hexagon, what's the definition of regular hexagon?
All of the sides are the same and all of the.
There's my attempt to try to draw a regular hexagon. And you put a dot in the center.
That is equal away from all of them. Yep.
So how many different triangles are there?
5, 6.
How many different triangles are there?
0. There's only one.
There's only one. So guess how you prove that this hexagon is the same as another regular hexagon?
Use that.
You just need to show that one triangle of one is congruent to one triangle of the other. So it's not like you really are if you had 100 gone, as long as it's regular, right? That you have to show, let's see, 100 times 2, 200 different parts are congruent to 200 different parts. You just got to show that one triangle of one polygon is congruent to one triangle of the other one, and you're done, as long as it's regular. Irregular, boy, we got our work cut out for us. Because then we got to prove that matching triangles are congruent. All right. So this is maybe more so, I don't know, maybe you guys have struggled with this as well too. So this can be challenging, this whole process of showing that one triangle is congruent to another one when you don't have a congruency statement. When you got a congruency statement, it's simple. When you have numbers, it's simple. The hardest one is when there's no numbers, it's just two shapes, and they're turned and twisted somehow. And in your brain, you gotta maybe flip it and then turn it so that they match each other. Notice I just didn't do it. I'm trying to match hands. Well, you can't because your hands don't match.
I can match my hand. Look there. Match.
No, you didn't place one on top of the other.
Yes, it is. It is on.
Are they oriented the same way?
Yes.
No, they're not.
Yes, they are. Look.
You have oriented the same way means if you call this my front is facing this way.
Oh, they
What
are
you
the-
just did is you had two things where their fronts are touching.
Now they're.
If they're oriented the same way, it would be like this. Now they're oriented the same way, but they clearly, by the way, these are not congruent because they're different.
But look, I
You
got it.
can't, your hands are not congruent.
Genetic mutation.
We got a left and we got a right. They're different from each other.
Can you have two left hands?
I know that you can have, more than 10 fingers. I don't know if you can have two of the same left hand. But I do know this, your right hand is not the same as your left hand, right? Clearly, they're mirror images
Unless
of
your
each other.
left hand's the same as your left hand.
Yeah, but they're not. Now your front is your back is your front.
But no, but this is still part of my hand. I can.
Unless you have two left hands.
Hold your hand the same way. Point the front of your hand, whatever you want to define as the front, in the same direction.
This is the front and this.
Okay, where's your thumb?
I define both of them as the front.
It's not on the same side.
But I can mutate it to the other side, or use the.
I will,
for-
no, we're not going to get some scissors and mutate ourselves. All right. So you have to be able to flip things around if you don't have a congruency statement, if you don't have congruency markings, if you don't have measurements, you got to be able to flip these around in your head. It won't be impossible, but some kids struggle at this. For the kids that struggle, I always recommend that maybe you redraw the shape. Convince yourself that the two match. I'm just going to show you this from homework. So, hey, we got the gold standard. Guess what we have?
Thin and wet.
What?
Thin and wet.
Well, yeah, we have a congruency statement. So we have a thin web, right? Or fine web? I don't know.
Or a new wet. A new wet.
Or a nif boo.
Or a nip boon it. Yeah.
Or an ifin woob. Something. All right. So, McKinley, give me the three pairs of corresponding sides.
F, W.
Whoa. On your side.
What F, FI and WE.
There's one,
IN and EB.
two,
And FN and WB.
there's three. Jack?
Okay. F and W, I and E and N and E.
All right. Would it be correct to say nif boo?
Yes.
That's her question. Would it be correct to say if oob? Okay. You see why she said no? McKinley?
Yes,
Why did she say no?
because E and I don't match up.
Because E and I do match
Oh
up.
wait, no, it's N and W that don't match up.
N and W do not match up. It should be N and B. Correct. Okay. You could say the other one as well too. Okay. So that one's the easy one. That's the gold standard. Here's the hard one. And I'm not saying this is very hard, but some kids can't do this. Do you see that there's two triangles there? Well, somehow it tells us those are the same triangles. It clearly don't look like the same triangle. So you got to, in your mind, convince yourself, how do you lay the, I don't know if you're going to top to bottom or bottom to top, how do you lay them on top of each other so that you can see which parts are corresponding? Obviously, one part is ridiculously easy. Which part? Which parts absolutely 100% match up?
B, C, and A, B. Oh,
Some people would say that. Some people would say, oh, I'll buy either one. If you want to go with the DC and AB, now you got to convince people which direction does it go.
A, B,
Okay, so what about the other one?
B, B, B.
You want to agree or disagree? That he said A, B, C, D.
Yeah.
Okay, so you got to convince yourself that that's the way to go. For me, when I look at the triangle, okay, well, if we all agree that this side, I'm looking at AB, Ben, and DC match up, then if you can notice that AB is connected to a, I don't know if we want to call it a long side and a short side. So if he started with A is that piece that connects to the long side. So which piece, D or C, connects to the long side? And that's how I would do that. So I'll agree with that.
Wait, so then also if CD and BA are parallel, you could prove that with one measurement that those two are congruent
How could you do that?
with alternate interior angles.
Well, you only proved that two, well, okay, I'll buy that. So you could prove that the angles are congruent, but how would you get to the sides?
Well, then if the angles are congruent, then the whole thing is congruent, and if the whole thing is congruent, then the sides are congruent.
Nope.
Wait, no, because they can be similar. Never mind. You
You could have a small one and a big one, and the angles could literally be the same.
Yeah, you probably don't.
So we would have to go one more. I mean, you're close. And by the way, that's what we will do when we prove these things. We just have to be able to say something about the sides. Okay? And literally, tomorrow's class will be about this very thing.
Well, you could say that the DB is like, well, you could say that DB is perpendicular to AB.
We would have to have. Well, we don't care. We could just from your one statement right there. We would get that the angles are all congruent, vertical angles. By the way, that also implies that, like you said, if these two are parallel.
Yeah.
What if they weren't?
That's it.
Okay. All right. So my suggestion on these is, okay, you can manipulate it in your head. And the reason why question number 5 starts with a congruency statement is because once you write the correct congruency statement, you don't need to look at the shapes ever again. So let's see, ABO. So I'm going from, okay, I'm on this side, and I'm going from the one connected to the long side to the one connected to the short side. So A to B. So I want long side to short side. So that would be CD. And what's the rest? What's the other letter left there? O. So once your congruency statement is done, then the rest of those questions are ridiculously easy. I would not look at the picture again. It'll just confuse you, and you could make a simple mistake. Okay? You good on these questions?
Yep.
All right.
Although these
The other 3 are easy as well. So
Can you deduce? Okay, so now we've proven that the two triangles are congruent, right? Can you deduce that O is at the midpoint?
yes, because it's in every single equation. Well, it's in
Well, how are you getting it?
it's
then
in
it's
the
the
congruency
midpoint.
statement. ABO is congruent to CBO. O is in the middle of both.
Say it one more time slowly.
DC and O and AB and O both have O at the end, which is because
Yeah,
it's
that's
in
the
middle.
triangle. That's a vertex of a triangle. So
Yeah.
go ahead, Anna. Why is O the midpoint?
Because
Oh,
from the statement when it says that O is corresponding or congruent to O.
Okay, that's an angle. That's not a midpoint. What do you got?
Since the triangles are congruent, that means that AO and OC are congruent and BO and OB.
Well, we can stop right there with that one little statement. What did I just do? Man, I put congruency marks on AO and OC.
they're equal on both sides.
Therefore,
That's
That O is the
by the
definition of a midpoint.
definition of a midpoint, right? There you go. That, you could have continued and said, okay, well, that means this is congruent to that. All right, remember that for tomorrow. All right, suppose that DB, where's DB?
Oh, I
DB
can do it.
is,
No, DC is congruent to AB.
no, I was skipping number 11.
Wow.
All right, well, let's do a 10 then. Explain how you can deduce that the two sides are parallel.
Alternate interior angles.
Do you remember what the proof of that? I mean, not the proof, but the,
Positive.
because this was, no, it was,
No, it's
it's the converse to something.
It's the converse. It's a theorem in itself. It's theorem 3.8. No.
This is more of a can you use your book of truth thing. What says that if alternate interior angles are congruent, then the lines are parallel? If alternate interior angles are congruent, then
theorem
3.5. And like I said, this is going to be what geometry is like from now on. It's like, oh yeah, we had that one theorem.
Yep.
And then you're going to be flipping through your book left and right. And this is why we try to stress that you got to keep it neat and orderly. Okay, so that's true. Okay, 11. Suppose you know that DB is perpendicular to DC. DB is perpendicular to DC. Okay, great.
And then you know that.
Explain how you can deduce that DB is perpendicular to BA.
Well, you know because you could do it 2 ways.
You do a proof, and the proof
Okay,
gets,
give me the proof.
I don't wanna go all
I don't
over
wanna
this
go
with
through all
alternate
that.
interior angles.
You could use alternate interior angles, sure.
Or you could use.
Or you could say,
If O is in
just show that the two angles are congruent. What do you know about D and B?
they're the same.
They're corresponding, right? You're like, wait a minute, they're alternate interior. Well, they're corresponding parts of those congruent triangles. So D matches with B. So I like the alternate interior angle. That would work as well too. But you could also say that they're corresponding. CPC. This is how you use CPCT. By CPCTC, therefore, that angle ABO is also 90 degrees. And then, therefore, they form perpendicular segments. All right, cool. Remember, this also applies to all polygons. All polygons. Hey, no congruency markings, just measurements. So this is method number 4. So it's saying these two are congruent. Okay?
okay?
So B corresponds with?
B corresponds with E.
Absolutely not.
No,
R.
R.
R. Black would correspond with?
Yes.
Okay, so I'm going BL,
True.
and we just said B
Right.
corresponds with R, so that would be R. What is it? Rojas? Black Rojas? I thought it was supposed to be black horses. It's not black horses?
No.
That wouldn't
Well,
be
it'd be
right.
black horse.
Well, horse.
Yeah, but
Thank
that
you.
can't be right.
It's not black horse. Why wouldn't they do it so it's black horse?
Elf. Because they're horrible people.
Black horses are horrible people?
No, the people. who
Oh,
are
the wrote the
doing-
book. Agreed. Yeah. It should be black horse, right? If they really
Well,
want.
Roses is a type of species. It's a watermelon combined with a hippopotamus.
Roche. What is hippopotamus in Latin or Greek?
Hippos.
What is hippopotamus in Latin or Greek? I believe it's Greek. Hippopotamus means?
Water horse.
It means water horse. Yes.
Wow, good guess.
Did you know that before? Or did you take a guess?
Yeah.
Well, that's a pretty darn good guess. Holy cow. All right, let's finish this up.
It's C.
Angle E goes with
C.
KB would equal to
Would equal to S.
4 centimeters.
4 centimeters. And give me the two right angles that you see.
H.
It says if
Angle A.
CA is perpendicular to LA.
Angle A and angle H.
There you go. Got it?
Yeah.
All right.
Bottom left.
IQ test. Ben, this is for you, Ben.
Bottom left, because the one on the bottom left, the tail or the bottom of the leaf is curved to the left, while all the others are curved to the right.
Do that so quickly.
Wow, good job.
Because I've already done the homework.
No. Never mind.
Look at, I didn't
You
read the
failed.
problem.
That's good.
Wait.
I don't think that's for homework, though.
No, that's class.
Yeah, if you did this for homework, Ben, you did extra homework.
I
Right.
did. Wait, how much you had to go to?
Yeah, but I gave you not classroom exercises, I gave you written exercises.
Wait, I did classroom?
If you did the one with the leaves, you did classroom.
Are you serious?
Enjoy your homework, Ben.
Read into the homework.
Wait, oh, I have to check. I'm looking.
If you did the one with the leaves, you did classrooms.
So what do we need?
No, I did
So,
it.
you're gonna get a problem that looks like this.
Oh my gosh, it is. Seriously?
Ben, you're gonna be smarter for it.
That was pointless.
All right, Ben, I'll catch you later.
I've done that.
Bye.